Relative motion in rectilinear motion. Firstly, we need to know what exactly the rectilinear motion is. The rectilinear motion is the motion of objects which travel in the same line of space. When any two bodies are said to move in the same direction and in the cojoints then are said to be in rectilinear motion. Also, there exists a relative motion between these two bodies. For example, when two cars move in the same direction in the same line, then they have relative motion. The motion between them differs in terms of velocity, speed, frequency, and so on. They have relative motion that will be differing at different factors affecting them. It is also similar to the case where two people are moving in the same line of queue but have different speeds with which they move. Next will be the frame of references that we need to consider here, when two bodies are traveling in the same line of space given. So when 2 points are on the reference, we join them and get a triangle. Rectilinear motion is when the objects move in a straight line without any deviation. And when two such bodies travel in the straight line, we tend to calculate the relative motion between the objects in motion. Relative motion in circular motion. When the path of the motion of an object is in circles, then the motion is said to be in circular motion. When the object moves in such a manner, then the motion of the path is described by the circumference of the circle. And it also describes the length of the circle, which is nothing but the circumference of the circle. Now let us make use of an example of motion which will easily explain this types of motion. We consider the satellite that circles the Earth in its own circular path. The satellite will create a circular motion as the path of direction form. This we know that there is circular motion form a certain height from the Earth. There are several other satellites too that will circle around the Earth. When other satellites come into contact with each other, there seems to be a relative motion between the satellites. The speed of one satellite may vary from the other satellite, and when the orbit around the Earth, one seems to be in stationary while the other seems to be in circular motion, and vice versa. Another example is that, when you tie one end of string to a stone and the other end is whirled around, then it automatically makes a circular motion. So when two such stones are made to whirl around, they're said to be in relative motion to each other. Relative motion in rotational motion. For this section we shall now use an example. The fan can be one of the good examples for the rotational motion. We consider one plate of the fan while in its motion, then it is said to undergo a circular motion. But when we consider the whole fan system, then the system is said to be under the rotational motion. Generally, when the motion is said to be circular, then it should move along the circumference, but in this case it doesn't. The whole fan system is considered as one single object, and for an observer, the motion of the fan seems to be stationary as all the plates of the fan move at great speed. Consider a person lying on the floor while the fan is switched on, so when we are stationary, the fan also seems to be in stationary state. But the actual fact is that the speed of the fan is in such a way that it moves at great speed, and we notice it to be not moving. The axle is called the point of rotation, about which all the plates are connected to one single rotor which drives the plates of the fan into motion, and this motion is relative to the observer. Relative motion in axial motion. The axial motion is regarded to be the motion in which the object rotates in circular motion along with the axis of its rotation. How is the type of relative motion comes under this section, you might think? The answer is simple and can be explained using a real-world experience. Let us consider the solar system for this purpose. Now we all know that the planets in the solar system rotate and revolve in a certain direction at certain speed. So we shall see the Earth as the best example for this. When Earth rotates on its axis, it is relative to the motion which it revolves around the Earth. From the Earth, if we see other planets, they seem to move in the opposite direction where they seem to be in motion, but we do not realize that we too are in constant circular motion. It is called the relative motion in general. The motion of Earth and the other planets are in relative to each other. So we take other satellites to be in motion and they seem to appear in stationary state from viewed from other satellites. For example, say a satellite is launched from India is revolving around, but the satellite from China too revolving around the Earth. The two satellites are said to be on relative motion to each other. The motion between the planets and satellites can be one of the best examples for the types of relative motion. Relative motion in one-dimensional motion. Generally, when we consider a motion of any object, we say that they are acting under from different frames of reference. But there are certain times where the motion occurs in one- or two-dimensional. Generally, a projectile motion is considered to be the one-dimensional motion because it moves in one single direction. But when a football is kicked or thrown from one end to another, there will be a relative motion between the player and the ball and the player on the receiving end. We call this a two-dimensional motion where the relative motion comes into act. Generally, when the motion of any object that occurs in two different directions at the same time. So there will certainly be a relative motion between the objects. In a one-dimensional motion, we consider a projectile motion and also a falling object. Here only the object thrown or falling is in relative to the person on the other. Therefore, we consider this motion to be one of the types of relative motion. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.